Ancient stories of worldwide floods appear in over 500 cultures across the globe. Today, we are discovering that these legendary deluges might be rooted in real geological events. By the end of this exploration, you will see how modern science is transforming mythical tales into credible chapters of Earth's history. We will investigate why civilizations from Mesopotamia to the Americas all tell such similar stories, and what clues lie buried in stone and sediment. Are we finally uncovering the truth behind humanity's most persistent memory? More than 500 distinct cultures, separated by vast oceans and towering mountain ranges, all tell a strikingly similar story. From the ancient Mesopotamian epic of Gilgamesh to the Aboriginal Dreamtime stories of Australia, the narrative of a great, world-altering flood appears again and again. It is a global phenomenon that defies simple explanation. How could civilizations with no known contact with one another develop such parallel accounts? The common threads are impossible to ignore, a divine warning often unheeded by the masses, a chosen few who build a survival vessel, the preservation of animal life. And finally, a new beginning for humanity on a cleansed Earth. This is not merely a collection of interesting tales. The sheer persistence of these narratives across isolated cultures strongly suggests they are preserving the memory of a real catastrophic event. These stories tap into our most fundamental human concerns, our fears about survival, our questions about morality, and our fragile relationship with the natural world. Such global consistency points toward a shared planetary experience, a deep-seated memory etched into the collective consciousness of humankind. This widespread distribution of the flood myth is not the end of the mystery, but the very beginning of our investigation, compelling us to look for the geological evidence that could turn legend into history. The very ground beneath our feet holds the first tangible clues. Imagine the gentle process of a river laying down silt year after year, creating a neat horizontal record of time. Now envision that process violently accelerated. Across the world, geologists find immense layers of sediment that tell a different story, one of sudden, catastrophic deposition. These are not the patient pages of Earth's history, but frantic, single-sentence paragraphs written by deluges of water. Some of these layers stretch for hundreds of miles and are thicker than a skyscraper is tall, a scale that defies ordinary river flooding. Within them, the fossil evidence is just as telling. Skeletons of land animals and deep-sea creatures are found jumbled together, a clear sign that terrestrial landscapes were swiftly and brutally drowned by ocean waters. Scientific dating techniques suggest many of these cataclysmic layers were formed just as human societies were beginning to form their earliest memories. A stunning example can be found in the channeled scablands of Washington State, a vast, scarred landscape that was not carved slowly over ages, but ripped open in a matter of days by a colossal wall of water. Similar evidence of profound submergence exists in the very heartlands of ancient myth, beneath the waters of the Mediterranean and across the submerged plains of the Persian Gulf. For a nascent civilization, witnessing such an event would be incomprehensible. The world they knew literally washed away and buried under mud and stone. Is it any wonder that the memory of such an earth-shattering event would be seared into their collective consciousness, to be told and retold for generations, slowly transforming from lived trauma into foundational legend? High on the slopes of the world's tallest mountains, geology presents a paradox that reshapes our understanding of the past. The silent, stone shells of ancient clams and the delicate skeletons of long-vanished sea creatures rest thousands of meters above the ocean. These are not the remains of land-dwelling animals that wandered too high. They are marine fossils, permanent residents of the Himalayas and the Andes, offering undeniable proof that the land beneath them was once the floor of an ancient sea. One of the primary explanations for this incredible elevation lies in the slow, relentless dance of plate tectonics. Over millions of years, the colossal plates that make up the Earth's crust collide, pushing the seafloor skyward to form majestic mountain ranges. But geology also reveals another, more urgent possibility. In certain locations, the evidence points not to a slow uplift, but to a rapid and catastrophic inundation, a marine transgression where the ocean itself rose to claim the land. The story becomes even more specific when we look at microfossils, the tiny, single-celled organisms that once floated in the ocean's surface waters. Their presence in sediment layers helps geologists map vanished shorelines with astonishing precision, identifying periods when sea levels climbed not gradually but with startling speed. Around the Mediterranean basin, for example, thick layers of marine sediment lie directly on top of the remnants of ancient human settlements. This is not a slow coastal erosion. This is a clear geological signature of a sudden, catastrophic submergence, a moment when thriving coastal communities were swallowed by the sea. Can you comprehend the stories that would emerge from such an event? The survivors, watching from higher ground, would have witnessed their entire world, their homes and their history, vanish beneath the waves. The memory of the day the ocean conquered the land would be unforgettable, a trauma etched into the very identity of a culture and passed down through generations as a warning from the gods. These elevated marine remnants are more than just curious rocks. They are the physical, tangible proof of a planet where landscapes were not just shaped by water, but fundamentally transformed by it. Beneath the waves, the past sleeps in silent ruins. Scattered across the world's continental shelves are the haunting remains of human settlements, now resting on the seafloor. Off the coast of India, the legendary city of Dwarka reveals stone structures and artifacts submerged in the bay. In the Black Sea, sonar maps outline the contours of Neolithic villages, their wooden posts and tools preserved for millennia in the deep, oxygen-depleted water. These are not mythical places lost to time. They are real communities once thriving on dry land that were claimed by the rising sea. Core samples taken from the sediment around these sites tell a clear geological story. They show a transition from terrestrial soil with evidence of freshwater plants and human activity to layers of marine mud filled with saltwater shells. This shift marks the moment the ocean arrived, and it often coincides with periods of rapid environmental change at the end of the last ice age. The preservation is sometimes startlingly intimate. In some locations, archaeologists have found not just pottery and tools, but the actual footprints of individuals pressed into the ancient, now drowned shoreline, a final snapshot of a day interrupted by an encroaching tide. Carbon dating consistently places these inundations within the last 10,000 years, a pivotal era when human societies were first forming villages and forging their earliest collective memories. Consider the profound cultural impact of such an event, an entire community watching their homes, their sacred spaces, and their livelihoods slowly or suddenly vanish beneath the water. The displacement would have been total, forcing survivors to carry with them not just their possessions, but the overwhelming story of their loss. This was not a simple change of address. It was a tearing of their world, an event so monumental it would demand explanation for generations to come. Is it any wonder that the story of a great flood, a punishment or a reset from the gods, would become the central pillar of their identity? These underwater ruins are more than archaeological curiosities. They are the tangible, physical evidence that the floodwaters of legend did indeed rise, swallowing the homelands of our ancestors and forever altering the course of human history. These frozen and wooden archives offer a timeline written in ice and wood. Deep within the ice sheets of Greenland and Antarctica, scientists extract long cores, each layer a frozen snapshot of a past year. Trapped within that ice are tiny bubbles of ancient atmosphere, preserving a direct record of the world's climate at that moment. By analyzing the subtle chemical signatures in these ice layers, particularly the ratios of different oxygen atoms, researchers can read the planet's temperature history with remarkable precision. What these records reveal are not just slow, gradual changes, but dramatic, abrupt spikes in global temperatures. These sudden warming events, occurring at the end of the last ice age, would have been absolutely catastrophic in their effect. They triggered the collapse of continental ice sheets, releasing unimaginable volumes of fresh water into the world's oceans in geologically short periods of time. This was not a gentle rise, this was a violent surge. At the same time, on mountainsides where little else can live for millennia, ancient bristlecone pine trees have been patiently recording history in their rings. Each ring tells a story of that year's conditions. A wide ring signifies a year of plentiful rain and robust growth. A series of narrow, cramped rings reveals years of severe drought and hardship. By studying trees from different continents, a startling pattern emerges. Around 5,000 years ago, tree rings across the globe show a synchronized signal of extreme climate disruption, a period of wild swings between deluge and drought. How would such chaos have impacted the first human civilizations? These were societies utterly dependent on predictable seasons and reliable water sources for their fledgling agriculture. A sudden, massive meltwater pulse raising sea levels by several meters would have inundated every coastal plain on Earth, the very places where early humanity tended to build its first permanent settlements. Simultaneously, the climate instability recorded in the tree rings would have caused rivers to swell far beyond their banks or vanish entirely, destroying harvests and wiping out communities. The independent stories told by the ice and the trees converge on the same conclusion. The world our ancestors knew became profoundly unstable. The ground could literally disappear beneath the waves, while the skies turned against them with unfamiliar fury. Is it any wonder that the memory of this global trauma, a time when the very elements seemed to revolt, would be seared into the cultural memory of every surviving society? These natural archives do not record the names of kings or the details of battles, but they do provide the undeniable environmental backdrop against which humanity's most enduring legend was born. The great river deltas of the world hold their history in layers like a book written in mud and sand. Where the Tigris and Euphrates rivers meet the sea, the land is a vast flat plain built from millennia of sediment. Archaeologist Leonard Woolley, excavating the ancient city of Ur, made a startling discovery. He found a thick, clean layer of clay, nearly 3 meters deep, separating two distinct periods of human occupation. This was not ordinary river silt. This was a deposit from a catastrophic inundation, a deluge so immense it buried the entire valley under a temporary inland sea before the waters finally receded. Similar stories are locked in the soil of the Nile and Indus River deltas. Core samples extracted from these regions reveal a rhythmic pattern, alternating layers of fertile soil with sudden, massive deposits of sand and sterile clay. These are the geological signatures of normal river life punctuated by periods of utter chaos. In China, the legendary story of Emperor Yu taming the Great Flood finds its physical counterpart in the stratigraphy of the Yellow River Delta. There, geologists have identified layers of sediment that point to a colossal breach of the river's banks, an event so powerful it reshaped the landscape and displaced entire populations. Radiocarbon dating places several of these major flood events across different continents around 2900 BCE, a time that coincides with the earliest written records of humanity. These were not gentle overflows. They were existential crises for the early agricultural societies that depended entirely on these rivers for their survival. A single massive flood could wipe out a season's crops, destroy villages, and contaminate freshwater sources for years. How would a society process such a traumatic event? The memory of the river that gave them life suddenly turning against them with unimaginable force would be seared into their identity. It would become the defining story of their past, a warning of divine displeasure or a tale of a heroic struggle for survival. The geology of the deltas provides the physical evidence for these regional catastrophes, showing us that the great flood legends were not born from a single global event, but from 1,000 localized disasters, each one profound enough to echo through the centuries. The ocean itself can reach inland with terrifying force. Along coastlines around the world, geologists find a unique and chilling type of sediment layer. These are not the gentle deposits of a rising tide. They are the calling cards of tsunamis, immense waves that scoop up sand, shells, and even deep-sea sediments and hurl them far onto dry land. The signature of these events is written in the soil as reversed grading, where larger stones and chunks of coral settle on top of a layer of finer sand and silt. This upside-down sequence reveals a single, violent surge of water that lost its energy all at once, dropping the heaviest material last. One of the most dramatic examples comes from the North Sea. Around 8,200 years ago, a massive underwater landslide known as the Storegga Slide sent a towering tsunami crashing into the low-lying plains of Doggerland, a vast landscape that once connected Britain to mainland Europe. The wave did not just flood the land, it erased it, scouring the terrain and depositing a distinct marine layer over the submerged forests and freshwater peat. This event transformed an inhabited continent into a memory, sinking a world beneath the waves. Similar tsunami deposits have been identified along the coasts of the Mediterranean and Southeast Asia, dating to periods of intense seismic activity. For a coastal community living through such an event, the experience would be apocalyptic. A wall of water appearing without warning would sweep away everything in its path. Homes, temples, and entire villages would be obliterated in an instant. The survivors, left with only the story of the day the sea rose up and attacked the land, would be left to make sense of the catastrophe. How else could such a sudden, incomprehensible force be explained except as an act of a powerful, displeased deity? The geological evidence for tsunamis provides a direct and terrifying mechanism for the sudden, massive flooding described in so many legends. These are not stories of slow, rising water, but of a single, overwhelming wave, a divine punishment delivered from the sea itself, leaving an indelible mark on both the landscape and the human imagination. Hidden behind the calm face of a retreating ice sheet lies a force of almost unimaginable power. Across the northern hemisphere, as the last great ice age waned, colossal dams of ice held back vast inland seas of meltwater. These were not mere lakes but freshwater oceans trapped on land, some containing more water than all of today's rivers combined. The most fragile part of this system was the ice dam itself. When one of these natural barriers finally gave way, the result was a cataclysm. The water did not simply drain, it exploded outward in a torrential fury known as a glacial lake outburst flood. The landscape of eastern Washington state tells this story in stark, permanent scars. Here, the channeled scablands stretch for hundreds of miles, a bizarre terrain of dry canyons and giant potholes. This is not the work of slow erosion over millions of years. Geologists see this as the work of the Missoula floods, a series of catastrophic outbursts where glacial Lake Missoula repeatedly drained in a matter of days. The flow from a single one of these events was 10 times greater than the combined flow of every river on Earth today. This was not a flood, it was a continental-scale rearrangement of water and land. And this was not a unique event. Similar outbursts occurred across the globe wherever ice sheets retreated, from the plains of Siberia to the fjords of Scandinavia. Each rupture sent a wall of water, sediment, and ice crashing toward the ocean. The immediate local devastation is almost beyond description, but the global consequence was just as profound. Each of these colossal freshwater pulses would have rushed into the world's oceans, forcing sea levels to rise in sudden, dramatic jumps. For any human communities living along those ancient coastlines, the ocean would have seemed to be actively advancing, swallowing their homelands in a relentless, unstoppable march. How would a witness with no concept of distant ice sheets or glacial mechanics process the sight of such an incomprehensible volume of water appearing from the interior of the continent? The only possible explanation would be a story of a great deluge, a divine release of waters from the heart of the world itself. These outburst floods provide a geological mechanism of biblical scale, turning the slow-motion collapse of an ice age into a series of sudden, world-altering events that would have been remembered as the floods to end all floods. Deep within the silent darkness of limestone caves, another geological clock quietly marks the passage of time. Stalactites hanging from the ceiling and stalagmites rising from the floor are more than just beautiful rock formations. They are intricate climate archives built one droplet of mineral-rich water at a time. Each delicate layer of calcite, thinner than a human hair, holds a chemical signature of the environment above when it was formed. Scientists can read these banded records like the rings of a tree, identifying periods of abundant rainfall that accelerated their growth and extended droughts where their growth simply stopped. When researchers analyze spelyothams from caves across different continents, a remarkable pattern emerges. Around 5,000 years ago, the records from the Middle East, Asia, and the Americas all show a synchronous and dramatic shift. The chemical story locked in the stone tells of a climate whiplash, where severe megadroughts lasting for decades were abruptly broken by periods of intensely heavy, relentless rainfall. The precise chemistry of the oxygen atoms trapped in these layers reveals not just the amount of rain, but its origin and temperature, painting a detailed picture of ancient weather systems gone haywire. For the early agricultural societies living through this era, the impact would have been devastating. After years of crippling drought where crops failed and water sources dried up, the landscape would have been hardened and barren, unable to absorb a sudden deluge. Torrential rains would have then cascaded off the parched ground, gathering into devastating flash floods that scoured river valleys and buried settlements under mud. How would a community interpret such a violent swing of fortune? After praying for rain for so long, the heavens finally open, only to deliver a catastrophe. This was not a gentle seasonal change, but a fundamental breakdown in the natural order they depended on for survival. The cave formations provide independent physical proof of the very weather patterns that could have inspired the great flood legends. They show us that the cataclysm was not always a single wave from the sea, but sometimes a fury unleashed from the sky itself, a divine answer to prayer that became a punishment. High above today's crashing waves, a series of silent stone steps climb the hillsides of coastlines around the world. These are marine terraces, ancient shorelines now lifted and stranded far from the water's edge. Each flat bench carved by waves that have long since receded is a fossilized moment in time, a permanent record of where the ocean once met the land. By carefully mapping and dating these terraces, geologists have pieced together a global sea level curve, a graph that tells the story of our planet's emerging coastlines. The data reveals a staggering truth. Between 14,000 and 6,000 years ago, as the great ice sheets melted, the global ocean climbed by approximately 120 meters. This was not a smooth, gentle incline. The rise came in pulses and surges, with periods where the water advanced at a rate of 4 or 5 centimeters every single year. For us today, that might sound slow, almost imperceptible, but for the generations of humans living through it, it was a creeping, inescapable disaster. A community might build its village a safe distance from the sea, only for their grandchildren to witness the same water lapping at their doorsteps. Over a few centuries, entire coastal plains, rich with resources and history, would have been steadily consumed. The process was relentless, punctuated by terrifying accelerations. A sudden collapse of a distant ice sheet or a massive seismic event could have sent a surge of water inland, rapidly drowning areas that had been dry for generations. How would a culture process this slow-motion loss of their world? The stories passed down would not speak of a single storm, but of an ocean with a relentless will, a divine force gradually reclaiming the earth. These coastal terraces are more than just geological features. They are the physical contour lines of human memory, marking the very shorelines that vanished beneath the waves and gave rise to the enduring legend of the Great Flood. Volcanoes hold the power to reshape the world in a single, violent breath. Beyond the immediate devastation of lava and ash, their greatest impact unfolds in the sky, triggering cascading climate events that could lead to global flooding. Imagine a major eruption like the one that formed Crater Lake in Oregon around 5,700 years ago. When Mount Mazama collapsed, it ejected immense volumes of fine ash and sulfur gases high into the stratosphere. This veil of particles did not simply fall back to Earth. It spread across the continent, filtering sunlight and plunging regions into a volcanic winter. This sudden, deep chill would have had a paradoxical long-term effect. It could have stabilized and expanded ice sheets for a time, but the subsequent return to normal temperatures, or even a period of intense warming, would have triggered an accelerated, catastrophic melt. The evidence for this chain reaction is locked in polar ice. Deep within the ice cores of Greenland and Antarctica, scientists find distinct, sharp layers of sulfate, the chemical fingerprint of ancient eruptions. These acidic bands are precise time markers, and they consistently coincide with periods of dramatic climate disruption recorded in the tree rings and sediment layers we have already explored. A more recent example, the colossal eruption of Thera in the Mediterranean around 1600 BCE, demonstrates the multifaceted threat. The explosion itself likely generated immense tsunamis that ravaged coastal civilizations like the Minoans. At the same time, its volcanic plume would have cast a pall over the hemisphere, leading to years of cooling, failed harvests, and abnormal rainfall patterns. For ancient peoples, the connection would have been terrifyingly clear. They would have witnessed the sky itself darken for years, the sun turning red through the haze, followed by unseasonable cold and the failure of their crops. Then, as the atmosphere cleared, they would have faced a new horror, torrential rains and rapidly rising rivers, as if the heavens were finally emptying the reservoir they had been holding back. How could they not interpret this sequence as a divine drama, a story of angry gods darkening the sky before unleashing a purifying flood? Volcanology does not just offer another flood mechanism, it provides the spark, the climatic trigger that could have turned a stable world into one ripe for deluge, weaving the raw power of the Earth directly into the fabric of our oldest stories. Earth's magnetic shield is not a permanent fixture. It has faltered and even reversed its polarity entirely throughout our planet's deep history. The planet's own volcanic rocks hold a memory of this invisible force. When lava cools, tiny magnetic minerals within it lock in the direction and strength of Earth's magnetic field at that very moment, creating a frozen compass needle in stone. By studying these magnetic signatures in ancient lava flows and deep-sea sediments, scientists can map the history of our planet's protective shield. The records reveal periods known as geomagnetic excursions when the field weakened dramatically for centuries. A weaker magnetic field would have allowed far more cosmic and solar radiation to reach the Earth's surface. While the direct effects on life are complex, this weakening is often found in sediment layers that also tell a story of sudden climate shifts and rapid extinctions. It is as if the planet's own defenses flickered and chaos followed. This geomagnetic evidence intersects with another extraordinary possibility preserved in the ground, the telltale signs of cosmic impacts. Scattered across the globe are craters, some hundreds of kilometers wide, silent monuments to asteroid or comet strikes. More subtle, but just as telling, are thin, dark layers of sediment found on multiple continents, rich in iridium, a rare element on Earth but common in space rocks. These layers also contain microscopic diamonds and tiny spheres of melted rock, materials forged only in the intense heat and pressure of a massive impact. One of the most compelling theories, the younger Dryas impact hypothesis, points to evidence of such an event around 12,800 years ago. The proposal is that fragments of a comet struck the Earth, potentially destabilizing the massive North American ice sheet. The resulting chain reaction could have been apocalyptic, a rapid melt unleashing colossal floods into the oceans and plunging the northern hemisphere back into a temporary ice age. For any humans who witnessed the aftermath, the world would have become unrecognizable. They would have seen the sky light up with fire, felt the ground shake, and then endured years of a cold, dim sun, followed by rising, relentless waters. How would such a spectacle be understood? The very fabric of the sky seemed to tear open, and the elements revolted. The only framework for such an event would be a story of cosmic proportions, a divine conflict played out in the heavens with the Earth itself as the battleground. These paleomagnetic and impact records provide a truly celestial dimension to the flood mystery, suggesting that the trigger for our planet's great deluges may not have always come from within, but from the vast and unpredictable cosmos above. The very bones of our ancestors can tell us where they lived and what they ate. Locked within the enamel of ancient teeth and the structure of old bones are subtle chemical signatures, a permanent record of an individual's life. Scientists analyze stable isotopes, different forms of common elements, to read this biological archive. Strontium isotopes absorbed from the local soil and water reveal the geological fingerprint of a person's homeland. The ratios of carbon and nitrogen isotopes paint a detailed picture of their diet, distinguishing between foods gathered from the land and those harvested from the sea. When researchers examine human remains from regions known for ancient flooding, they uncover stories of sudden, dramatic upheaval. In the areas surrounding the Black Sea, for example, skeletal evidence shows a clear shift in human diet. The isotopic signatures change from those of people who ate land-based plants and animals to those of people who relied heavily on marine resources. This transition occurs at a geological layer that marks the proposed inundation of the ancient coastline. It is the story of a community that once hunted in forests and farmed in valleys, now forced to become a culture of fishermen and shoreline foragers, their entire way of life transformed by the advancing water. This biological evidence is supported by genetic studies of ancient DNA, which trace sudden population movements and mixing of different groups during these same turbulent periods. How would such a profound disruption be remembered? A people are forced from their ancestral lands, their traditional food sources vanish beneath the waves, and they must adapt to a completely new existence along a foreign shore. The trauma of that displacement, the loss of a familiar world, would become the core of a powerful narrative. It would be a story of a great cleansing or a punishment, a time when the old world was washed away and a new one, with new rules and new struggles, had to be built from the remnants. Bioarchaeology gives us more than just dates and data. It provides intimate evidence of human resilience in the face of catastrophic change, showing us how the memory of survival against impossible odds was forged into legend. The wind itself can write history in stone. Across continents like China, Europe, and North America, vast plains are not made of ordinary soil, but of a fine, yellow silt called loess. These are immense deposits of dust piled hundreds of meters deep, carried and laid down by ancient storms over thousands of years. This dust forms a different kind of geological book, one with pages made of alternating layers. You find bands of pure, sterile loess, representing centuries of dry, windy conditions when dust storms were constant. Then you find darker bands, ancient soils called paleosols, where the dust settled long enough for plants to take root and stabilize the landscape during wetter, more stable climatic periods. These Loess paleosol sequences are a rhythmic record of the planet's breath, cycles of aridity and humidity written into the earth. In China's Loess Plateau, this record holds a startling clue. Within one of these thick soil layers, geologists find evidence of an extreme, sudden event, a signature of catastrophic rainfall that would have devastated the landscape. This evidence aligns perfectly with the time frame of the legendary Great Flood of Emperor Yu, a foundational story of Chinese civilization about a hero who tamed a generation-long deluge. This was not just a seasonal storm, but a climate whiplash. After years of dusty drought, the skies opened with a vengeance. For ancient farmers, how would this have appeared? They would have endured years of hardship, their fields constantly threatened by blowing dust, only to be confronted by a new horror. Rain so intense they carved gorges through the soft landscape and triggered landslides of saturated silt. The land itself would have turned against them. Remarkably, the Loess records in Central Europe and North America show similar patterns of synchronized climate disruption at this time. The entire hemisphere seemed to be experiencing the same violent swings. This geology provides a continental-scale backdrop for humanity's flood stories, revealing a planet caught between dust and deluge, where survival itself depended on navigating the chaos between two elemental extremes. Coral reefs are living stone calendars, their growth forever halted just above the waterline. Along tropical coastlines from Barbados to Papua New Guinea, you can find these ancient reefs perched high on cliffsides, like bathtub rings left behind by a retreating ocean. Each fossilized terrace marks a moment when the sea stood still long enough for an entire ecosystem to build its foundation, only to be abandoned as the water level dropped or the land itself rose. These are not vague indicators, they are precise historical markers, and by applying uranium-thorium dating to the coral skeletons, scientists can read them with astonishing accuracy, reconstructing the ocean's height for the past 500,000 years. The story they tell is one of dramatic, punctuated change. Following the last ice age, the sea did not simply creep upward. It surged in rapid pulses, leaving behind a staircase of reefs, each step a testament to a sudden jump in the global water level. The timing of these surges is critically important. They occurred just as human communities were establishing themselves along the world's most fertile and inviting coastal plains. For an island culture, a rapid sea level rise of even a few meters would have been catastrophic, shrinking their habitable land, drowning their freshwater sources, and submerging the ancestral fishing grounds that sustained them. Generation after generation would have witnessed the ocean's relentless advance, a slow-motion disappearance of their world. What profound stories would emerge from such a loss? The memory of a larger, more bountiful homeland now resting beneath the waves would become a central pillar of their identity, a legend of a time when the sea gods grew hungry and claimed the land for their own. These coral terraces provide more than just data points. They offer a dated chronicle of the very events that likely inspired the most haunting flood legends of coastal and island peoples, turning geological fact into the bedrock of cultural memory. The smallest witnesses to Earth's great transformations are often the most eloquent. Billions of microscopic organisms, no larger than a grain of sand, carry within their delicate shells a perfect record of the world they inhabited. Diatoms, tiny algae encased in glass-like silica, and foraminifera, single-celled protists with intricate calcite shells, are not scattered randomly. Each species thrives in a very specific home, some in the fresh water of lakes and rivers, others in the salty embrace of the open ocean. When these tiny life forms perish, they sink to the bottom, layering the seafloor in a continuous, chronological archive of environmental change. To a geologist holding a deep-sea sediment core, these layers are like the pages of a detailed diary, written in a language of shape and chemistry. By identifying which species are present and analyzing the chemical signatures locked in their shells, scientists can read the ancient history of the water itself, its temperature, its salinity, and its depth with astonishing precision. In the sediments of the Black Sea, this microscopic record tells a story of sudden, violent change. The core reveals a distinct boundary where layers rich with freshwater diatoms are abruptly capped by a thick band of marine foraminifera. This is not a gradual mixing of two environments. It is a sharp line, a before and after, marking the moment around 5,600 years ago when saltwater from the Mediterranean catastrophically breached the natural barrier at the Bosporus and flooded the vast freshwater lake below. The same dramatic pattern is repeated in sediment cores pulled from the Persian Gulf and across the Mediterranean seafloor, each one showing a rapid shift from terrestrial or freshwater conditions to a fully marine environment. Can you fathom the human experience of such a transformation? A community living along the shore of a familiar freshwater lake would have witnessed the water slowly, then rapidly, turning brackish and undrinkable. The fish they relied on would vanish, replaced by strange saltwater species. The very character of their world, its taste and its smell, would be fundamentally altered in a single generation. This was not just a flood, it was the death of an entire ecosystem and the brutal birth of another. The silent testimony of these microfossils provides our most sensitive gauge of these ancient catastrophes, turning abstract legends of deluge into a measurable, chemical reality written in stone by the smallest of lives. Even the most delicate grains of pollen can carry the weight of history, preserved in the mud at the bottom of ancient lakes and in the deep, dark layers of peat bogs. These tiny, nearly indestructible particles form a continuous record of the world's lost plant life. Each type of plant produces pollen with a unique shape, a microscopic signature that allows scientists to identify what was growing in a landscape thousands of years ago. By extracting long cores of sediment and reading the changing pollen layers from bottom to top, researchers can watch entire ecosystems transform before their eyes. In regions with powerful flood traditions, these paleobotanical records reveal a dramatic and sudden pattern. The pollen tells a story of stable, dry land forests, dominated by trees like oak and pine, abruptly giving way to a different world. The core shows a sharp transition where the pollen of reeds, sedges, and other water-loving plants explodes in abundance, completely replacing the forest signature. This is the moment the land drowned. In Mesopotamia, pollen cores taken from sediment layers that date to around 2900 BC show this exact shift. The robust pollen of oak forests vanishes, instantly replaced by the delicate grains of marsh plants. This botanical revolution coincides perfectly with the thick layer of flood clay discovered by Leonard Woolley at the city of Ur. The land did not just get wet, it was fundamentally and permanently altered, its ecology rewritten by the invading waters. The same story is written in pollen across the globe, from the river valleys of China and India to the highlands of the Americas. How would a human community process such a profound change to their home? The landscape they relied upon for hunting, for gathering materials, and for spiritual connection would have been erased, replaced by an unfamiliar and difficult wetland. The very ground under their feet would have become soft and treacherous, the familiar trails swallowed by mud and standing water. This was not a temporary inconvenience, but a complete overhaul of their relationship with the environment, forcing a radical shift in how they found food, built shelter, and simply survived. The silent, patient testimony of pollen grains provides the ecological context for the flood, painting a vivid picture of a world lost and a new, challenging one born from the deluge. Deep within the stillness of a cave, a single drop of water hangs from a stone icicle, holding a secret from a forgotten sky. These are Spelyotham fluid inclusions, microscopic time capsules sealed inside growing cave formations for millennia. Each tiny, trapped droplet is a sample of ancient rainwater, perfectly preserved with its original dissolved gases and chemical isotopes intact. To scientists, these inclusions are not just water, they are a direct window into the atmosphere of the past. By piercing these microscopic bubbles with a fine laser, researchers can release and analyze the water molecules that fell as rain thousands of years ago. The specific ratios of hydrogen and oxygen isotopes act as a natural fingerprint, revealing the water's source and the temperature of the air when it originally evaporated from the ocean. This data allows us to reconstruct entire weather systems, distinguishing between gentle local showers and torrential monsoons pulled from distant seas. When experts analyze inclusions from caves across Europe, Asia, and the Americas, they find a consistent and startling story. The geochemical records from multiple continents show sharp, synchronous spikes indicating periods of extreme, sustained rainfall. These deluge periods align perfectly with the proposed timings of great flood events identified in sea level curves and sediment cores. The evidence suggests not just a single storm, but a fundamental reorganization of global weather patterns, leading to years of relentless precipitation. From the perspective of an early farming community, such a shift would have been incomprehensible. After planting their crops with an understanding of the seasons, they would have watched the skies darken and remain that way. The rains would not stop, river valleys would have swelled into inland seas, and the very soil would have liquefied, sliding down hillsides and burying everything in its path. How would a culture process such a permanent grayness, such a constant drumming on their roofs, and the slow, inexorable loss of their fields to the mud? The memory of a time when the sky itself seemed to break open would become a fundamental part of their history. These fluid inclusions provide the most intimate evidence yet, transforming abstract climate data into the very raindrops that may have fueled the floods of legend. The layered ground of ancient cities holds a rhythm of disaster and recovery. archaeologists carefully peel back the history of these sites, known as tells, revealing a story not written on tablets, but in soil and stone. Between the floors of old houses and the foundations of new ones, they often find a stark, silent layer, a band of pure silt or clay devoid of any human traces. This is the ghost of a flood, a period when life was interrupted and the town was buried under mud. At the legendary city of that layer of sterile clay is nearly 3 meters thick, a clear line separating one era of civilization from the next. In Troy, the story is written in fire and water, with multiple destruction layers suggesting that earthquakes and the tsunamis they spawned repeatedly shattered the city. The same pattern emerges far to the east, at sites like Mohenjo-Daro in the Indus Valley and Lajia in China, where sudden, violent deposits of sediment entombed entire communities. Radiocarbon dating consistently pins these disaster layers to the same centuries that local cultures began telling their foundational flood stories. How would a society process such a profound break in its history? The destruction was not the end of their story, but a brutal turning point. Survivors would have returned to the mud-choked ruins of their homes, digging out what they could and starting again, layer upon layer, directly on the graves of their past. The memory of that catastrophe, the day the earth turned to water, would become the central, defining event of their identity. A story of survival against impossible odds told and retold until it was woven into the very fabric of their mythology. This archaeological stratigraphy provides the ultimate human context, showing us that the great flood legends were not born in abstraction, but in the literal ground upon which our ancestors lived, died, and chose to rebuild. A river's path is not written in stone, but in sand and silt. From high above, the land reveals its history in sweeping curves and graceful arcs, the ghostly imprints of ancient channels that once carried water and life. This natural migration is usually a slow dance, but geology shows us it can also become a violent lurch. During periods of extreme flooding, a river can tear through its own banks in a process called an avulsion, abruptly abandoning its age-old course and carving a new one across the landscape in a matter of days. Sediment cores extracted from the floodplains of the Yellow River in China tell this story with stark clarity. They reveal layers of coarse sand and gravel deposited during single, catastrophic events, evidence of the moment the river broke free from its confines. Historical records and geological surveys confirm the Yellow River's mouth has shifted dramatically many times, with one legendary shift around the year 1320 BC displacing millions and fundamentally reshaping the region's geography. This pattern is not unique to China. In the Indus Valley, the Tigris-Euphrates system, and along the Nile, the same geological signature appears, a testament to rivers that rebelled against their own boundaries. For an ancient farmer, this event would have been world-ending. The river that provided water for their crops and defined their territory would suddenly vanish, its life-giving flow replaced by a dead, sandy trench. Or worse, a new, raging channel could appear without warning, scouring away fields and villages in a single season. How would a society explain such a fundamental betrayal by the landscape they depended on? The only framework that could contain such chaos was a divine one, a story of gods or spirits who were displeased and had rewritten the very map of the world. The silent, sinuous paths of these abandoned river channels are more than just geographical features. They are the physical scars of real catastrophes that forced human societies to adapt, migrate, and ultimately, to craft the epic stories of a world remade by water. The quiet floors of ancient lakes hold one of geology's most precise clocks. In the deep, still waters, sediment settles in a perfect, annual rhythm, creating thin, paired layers known as varves. Each couplet is a single year in the life of the lake, a light band of summer silt laid down by spring meltwater, followed by a dark band of winter organic matter from decaying plant life. These laminated deposits can be counted back through time, just like the rings of a tree, building a continuous, high-resolution calendar of environmental change that stretches for thousands of years. When researchers examine these sequences, they are looking for the exceptional years, the layers that are dramatically thicker than the rest. These are the years of the Great Floods, when exceptional runoff from the surrounding landscape carried a heavy load of sediment into the lake, leaving an indelible, measurable mark in the mud. In Scandinavia, varve chronologies extend back an astonishing 14,000 years, their layers recording the precise moments when colossal glacial lakes drained in catastrophic outbursts. Remarkably, similar records from lakes across North America and Asia show synchronous periods of these thick, flood-borne layers, revealing times when entire continents experienced years of relentless, heavy precipitation. How would a community living by such a lake have experienced these years of exceptional runoff? They would have watched their familiar shorelines vanish, the lake water turning a thick, muddy brown as it swelled over their fishing grounds and crept toward their homes. The very resource that gave them life would have transformed into a threatening, unpredictable force. The annual rhythm of the varves, so regular and predictable, would have been violently interrupted, the story of that catastrophic year written in a layer of mud far thicker than any other. This geology offers us more than just evidence of floods. It provides an annual diary of the deluges that shaped the human world. These silent stone sentinels hold a record of the sky's forgotten moods. Deep within secure cave systems, stalagmites rise from the floor like ancient stone trees, their growth rings telling a story written in calcite and time. Normally, these formations accumulate at a patient, steady pace, one droplet of mineral-rich water at a time, but their growth is exquisitely sensitive to the world above. When researchers examine spelyothams from regions with powerful flood legends, they find dramatic anomalies etched into their structure. The smooth, continuous banding is suddenly interrupted by a visible hiatus, a period where growth simply stopped for decades or even centuries. In other formations, the very crystal structure changes, becoming cloudy or porous, a sign that the water dripping into the cave was chemically different, often much more aggressive. Uranium series dating allows scientists to assign precise dates to these disruptions, turning abstract patterns into a chronological timeline of catastrophe. In caves scattered across the Mediterranean and the Middle East, a remarkable pattern emerges. Multiple Spelyotham records show significant growth changes clustered around 2200 BCE. This was not an isolated event in one valley, but a widespread period of profound climate disruption. The story told by the stone is one of hydrological chaos. A long growth hiatus could indicate a severe, generations-long drought that starved the cave of its steady drip of water. Then, when growth abruptly resumes, the altered chemistry points to a deluge of water, so abundant and acidic that it began to dissolve the existing formations even as new layers were laid down. How would a farming community, whose survival depended on predictable springs and reliable rainfall, have navigated such a violent swing? They would have endured years of desperate thirst, watching their wells run dry and their crops wither, only to be confronted by a new horror, torrential rains that flooded their fields and washed away the topsoil they depended on. The very ground beneath them, and the stone deep within it, was reacting to a climate system gone haywire. These Spelyotham anomalies provide a silent, subterranean witness to the extreme environmental stress that would have seared the memory of both drought and deluge into the human story. Where a mountain stream meets a flat plain, it often drops its heavy load of sediment, building a vast, gently sloping cone of sand and gravel. These alluvial fans are the geological equivalent of sand pouring from an hourglass, patiently recording the history of water and erosion. The very shape of these formations tells a story, a steep slope indicating a powerful, sediment-laden flow, while a gentle grade suggests a more patient river. By analyzing the size of the stones and the layers within these fans, researchers can read the intensity of ancient flood regimes. In the Dead Sea Basin, for instance, the alluvial fans are not just static landforms. They reveal distinct pulses of accelerated growth, periods when enormous volumes of coarse debris were dumped onto the plain in a series of catastrophic events. These growth spurts in the rock record align with other evidence of regional flooding, creating a consistent picture of hydrological chaos. This pattern is not isolated. Across arid regions from the American Southwest to the foothills of the Himalayas, alluvial fans show similar evidence of punctuated growth, indicating that even the driest landscapes were periodically scoured by exceptional, mountain-born deluges. Advanced optical dating techniques, which measure when sediment grains were last exposed to sunlight, now provide a precise timeline for these violent episodes. For a desert community living in the shadow of such mountains, how would they have understood these events? Their world, typically defined by scarcity and patience, would be violently interrupted. A sudden, thundering torrent would burst from a dry canyon mouth, carrying not just water, but a crushing wave of boulders and mud, reshaping the landscape in a single, terrifying day. The life-giving water they prayed for would arrive as an uncontrollable, destructive force. The memory of such a paradoxical catastrophe, a bounty that destroys, would demand an explanation, likely woven into a legend of divine anger or a great flood meant to cleanse the world. These silent, stony fans are more than just geological features. They are the physical archives of the desert's forgotten storms. Powerful computer simulations now allow us to rewind time and witness these ancient cataclysms. Paleo-tsunami modeling takes the geological evidence, the sediment deposits and the shape of the ancient seafloor, and uses complex physics to breathe life back into these long-vanished waves. Scientists input data from submarine landslides like the colossal Storegga slide, and the programs calculate the resulting wave's height, its speed, and just how far inland it would have marched. For the Mesolithic people of Doggerland, a vast plain connecting Britain to Europe, the models paint a terrifying picture. The simulations show that around 8,200 years ago, a wall of water tens of meters high would have raced across that low-lying landscape, scouring it clean and making it vanish forever beneath the North Sea. The same techniques applied to the Mediterranean reveal how a single, massive underwater landslide near Sicily could have sent tsunami waves crashing into coastlines hundreds of miles away, inundating entire river valleys and reaching many miles inland. How would a Stone Age community have described such an event? A roaring, unstoppable wall of water appearing on the horizon, devouring the world they knew. It would not be seen as a natural disaster in the way we understand it today. This was the sea itself rising up in fury, a divine punishment made terrifyingly real. These digital reconstructions provide the mechanics behind the myth, showing that the great floods of legend could indeed have arrived not with slow rising water, but with the sudden, apocalyptic force of a wave that reshaped continents. The very stone that drips from cave ceilings holds a chemical memory of ancient skies. We can now read this history through the subtle language of isotopes, different forms of the same element that tell a story about their origin. Inside cave formations like stalactites and stalagmites, the precise ratio of two oxygen isotopes, oxygen-18 and oxygen-16, is locked into the growing calcite. This ratio acts as a natural thermometer and rain gauge. A higher proportion of the lighter oxygen-16 often indicates periods of intense, heavy rainfall, as this isotope evaporates more readily from the ocean and falls first in a storm system. By analyzing these isotopic signatures with incredible precision, scientists can reconstruct past rainfall patterns with a resolution that can distinguish between different seasons thousands of years ago. When researchers examine spelyothams from caves across Asia, a dramatic story emerges from the chemistry. The records show a powerful intensification of the monsoon system around 5,000 years ago, a period of isotopically light rainfall that suggests the skies opened with a fury that would have been completely overwhelming. This same signal of dramatically shifted rainfall patterns appears in Spelyotham records from South America and Africa, hinting at a widespread reorganization of the planet's atmospheric circulation. For the early agricultural societies living in these regions, such a change would have been catastrophic. Their carefully managed fields, designed to handle normal seasonal rains, would have been utterly defenseless against this new reality. River valleys would have transformed into raging torrents, and fertile plains would have become shallow inland seas, washing away not just a single harvest but the very foundation of their way of life. How would a community explain such a fundamental betrayal by the weather patterns they had come to rely on? The only framework that could contain such a monumental shift was a story of divine intervention, a legend of a great deluge sent to reset the world. The silent, chemical testimony of cave formations provides our most detailed climate record for these pivotal moments, turning the abstract concept of a global flood into a measurable, seasonal reality written in stone. The silent ruins of ancient cities are not just piles of stone, they are intricate puzzles waiting to be read. To solve them, geologists and archaeologists join forces in a field known as geoarchaeology, peeling back the layers of history to understand how both people and natural forces shaped the places they called home. At remarkable sites like Çatalhöyük in Turkey, one of the world's earliest known towns, this partnership reveals a story written in mud. The soil tells of a community that thrived for centuries on a fertile plain, only to have its existence repeatedly punctuated by devastating floods. You can see the evidence in the very walls of their homes, where layers of mud brick are suddenly separated by thick bands of sterile silt, a clear sign that water inundated the entire settlement, forcing a pause in its long history. At Tel Leilan in Syria, the story is told through the smallest of details. Scientists examine paper-thin slices of soil under a microscope, a technique called micromorphology, to see the story written in the grains. They can distinguish the gentle, purposeful layering of a clay floor from the chaotic, churned-up sediment left behind by a violent rush of water. They analyze the soil's chemistry and its magnetic signature, which can reveal whether a layer of earth was deposited by human hands or by a raging river. What emerges is a timeline of crisis and adaptation. The archaeological record shows communities taking emergency measures, reinforcing their walls with sturdy buttresses, and raising the floors of their homes higher and higher in a desperate attempt to stay ahead of the rising waters. How did these ancient societies cope with such a relentless threat? Their response is etched into the very ground they built upon, a testament to human ingenuity in the face of a changing world. Geoarchaeology provides the ultimate integrated evidence, showing us that the great flood legends were not just stories, but lived experiences that forced our ancestors to constantly innovate, rebuild, and find new ways to survive on an unpredictable planet. The stone icicles of deep caves hold a chemical diary written in elements we can barely see. Beyond the broad climate stories told by oxygen isotopes, the patient drip of water also locks away tiny traces of other minerals, a subtle record of the water's journey through the rock above. Elements like magnesium, strontium, and barium are dissolved from the bedrock and carried into the cave, where they become permanently entombed within the growing spelyotham layers. The amount of these trace elements is a direct response to the water's flow. During periods of intense, sustained rainfall, water gushes through the soil and fractures in the rock, dissolving far greater quantities of these minerals and delivering a much richer chemical cocktail to the cave below. Scientists use a technique called laser ablation, which vaporizes tiny portions of the spelyotham with a precise beam to read this layered chemical history line by line. The results from caves in flood-prone regions are striking. In spelyothams from Southeast Asia, analysis reveals dramatic peaks in barium concentration around 4,000 years ago. This specific chemical signature is a clear indicator of massively intensified monsoon rainfall, where relentless downpours flushed water through the landscape at an unprecedented rate. The very same pattern, this sudden chemical surge, appears in Spelyotham records from Europe and the Americas, pointing to a period of global hydrological upheaval. Consider the human experience of such a change. For generations living near these caves, the environment itself would have transformed. The steady, familiar dripping from the cave ceiling might have become a constant, rushing trickle. The water that collected in pools might have tasted different, sharper, laden with minerals from the saturated earth above. How would a community have interpreted these subtle but pervasive changes in their world? The very springs they relied on would have flowed with unfamiliar water, and the skies would have remained a threatening gray for years on end. The trace elements in these cave formations provide a silent, chemical witness to the sheer volume of water that saturated the planet during these ancient deluges, turning legendary accounts of endless rain into a measurable, elemental reality written in stone. Our journey through the stones and sediments of our planet reveals a profound truth. The ancient stories whispered across generations are not mere fantasy. They are the echoes of real events, geological memories preserved in the rhythm of human speech. We have walked through immense layers of sediment laid down in sudden catastrophe. We have stood beside marine fossils lifted high onto mountain peaks, and we have seen the silent ruins of villages sleeping on the seafloor. The evidence from ice cores, tree rings, and cave formations all tells the same story, a story of a world emerging from an ice age into a period of profound instability, where sea levels surged and the climate swung violently between drought and deluge. This convergence of data from so many different fields of science does not strip the old legends of their power. Instead, it grants them a new, deeper resonance. These myths were humanity's first science, our ancestors' brave attempt to make sense of a world that seemed to turn against them with unimaginable force. They were recording the trauma of lost homelands and the triumph of survival, encoding vital lessons about resilience and adaptation into the very bedrock of our cultures. As we now face our own period of rapid environmental change, these stories speak to us across the centuries. They remind us of our shared vulnerability to the forces of nature, but also of our incredible capacity to endure, to rebuild, and to find meaning even in the face of catastrophe. The dialogue between the hammer of the geologist and the voice of the storyteller continues, revealing not just the history of our planet, but the enduring spirit of the people who have always called it home.